Okay, and welcome. And here we're going to go through some problems from week 2 for the material that you're learning in week 2 in discrete structures. This is the rest of the classwork problems you didn't get to. This is part 2 of that video. So the next question we're going to deal with a combination. We're dealing with combinations. So how many ways could a 10-question true-false survey be answered? And the assumption here is that every answer is either true or false. You answered every question. So if you look at the possibility tree, you start with the first question, and then the second question, and then the third question. You make a tree. The first question could either be a true, or I would need a much bigger paper to finish this, so I'm not going to, or false. And then once you answer that first question, the second question is independently either true or false. It doesn't matter how you answer the first question. You still have those same two choices. And then after answering the second question, you could have answered 1 true and 2 true, and you could still answer 3 could be true, or 3 could be false. If you went true for 1, false for 2, you could still answer 3 is true, or 3 is false. Hopefully, most of you are computer science majors, hopefully you're seeing this pattern here. Is that from each branch, I get 2 new branches until I'm done. Well, that makes this kind of a base 2 exponential. So how many choices for the first one? There were 2 choices for the first one. How many choices for the second one? There were 2. How many choices for the third? There were 2. And you're going to multiply every time you get one more question, the number of paths you get. The number of choices for each question remains at 2, but the number of paths you get, you'll end up with. So here I have 1, 2, 3, 4, 5, 6, 7, 8. No coincidence, that's 2 to the third. At the end of the third question, I have 3 paths. So for 10 questions, I'm going to have 2 to the 10th possible ways to answer that. So if you're, thinking you're just going to guess at a 10-question multiple choice test, the chances of doing well are pretty slim because there are 2 to the 10th possibilities, and you're only going to pick one set of those possibilities. So that is 1,024 when you multiply that out. That's a lot of possibilities. So for you to get the answer set that happens to be 100% by guessing, the probability is 1 divided by 1,024. We don't get into probability in this course, but this counting unit is really where you figure the size of the sample space for a probability question. We don't really go too far into probability, but you see that in a statistics course and then in other courses certainly. All right, so how if we change this up? In question 2, we can have a true, we can have a false, or we can have a blank. Now, I would have a third choice here, and a third choice here, and a third choice here. You see what happens? A third choice here, and a third choice here. So it becomes a base 3 exponential, and that's 3 to the 10th choices, and that's a whole lot of choices. I did that one out already, and it's 59,049. So blank is never going to be a correct choice on one of these tests, but again, the odds of guessing and getting anything right are 1 in 1,024 if you fill them all in. But how many different combinations of answers? And it's almost how many different permutations, because order matters. Set problem 1 is a particular answer, but there's 59,049 ways the answers could come out if you considered the set ordered 1 through 10. So it's almost like a permutation. It's one of those gray areas. We're going to get into the real difference between a permutation and a combination in a moment, probably in the next video. So what's the size of the power set of A if A has 5 elements? So remember the power set has is the set of all the subsets. So if the size of A is 5, I want to know how many power sets. Well, I can't really do this out for a set size 5 because it turns out it's 32. It's a lot of them. But if this is your set, start thinking about how you would write all of the subsets. So the power set, if this is A, so A has a cardinal number of 5. That's why I put 5 elements there. The power set, and that's a fancier P than that, of A equals, and I would start, okay, so first I have the empty set. Then I have the set that contains everything. So in each of these sets, each element is either in or out. The 1 is either in or out of the set. In the empty set, it's out. The 2 is out. The 3 is out. The 4 is out. The 5 is out. So each of these elements have two choices as to whether they can be in the set or they can be not in the subset. So I'm making a set of subsets. So each element of the power set is a set itself. Then I would do 1, then I would do 2, then I would do 3, then I would do 4, then 5, then I'd do 1 and 2, 1 and 3, 1 and 4, 1 and 5. You'd see I'd have a lot of them. Without writing them all out and being sure that you wrote them all, the size of a power set is, so if the power set has 5 elements, it's 2 to the 5th. So the size of any power set, that's the set of all subsets, for a set with cardinality n is 2 to the n. And the 2 comes from the fact that for each element, there's 2 choices for whether they're in or out of the set. Okay, so that's the end of kind of the combinations thing, or the how many thing. I'm going to go into permutations. Now, I did put the formula up for this in class. The difference between a permutation and a combination is this. If I look at the problem of how many ways 2 students can be chosen from a group of three, I'm just going to send 2 people to do something together. There's no particular order, no label on what they're doing. Well, that's how many subsets of size 2 can I get from 3. And basically, when you have 3 things, student A, student B, student C, the ways you can get 2 out of the 3 is you leave each one out. So there are 3 ways you can choose 2 groups from a set of 3. So that's a combination. We see that's a 3 choose 2, or a 3, this is actually in your sorry, that should be a 2, in your calculator. And the formula for that is, so this is n choose r. So I'm going to write the formula with n's and r's. I have at size n, and I'm choosing r from it. I have n factorial over r factorial times n minus r factorial. Now, it turns out r factorial is how many ways you can arrange 2 things. If I have student A and student B, I can arrange them this way, or I can arrange them this way. So you divide by the fact that students A and B contribute 2 arrangements. So this takes out, this r factorial takes out the fact that there are multiple, that you could choose A first, then B, B first, then A. This just says you end up with A, B. This allows you to say, it doesn't matter. All you know is that the set contains A and B, and the order doesn't matter. If you do, so this answer would be, this one, 3 factorial, which is 3 times 2 times 1. A factorial is just keep multiplying till you get to 1, reducing the integers by 1, over 2 factorial over 3 minus 2 factorial, which is just 1 factorial. 1 factorial is 1. The other thing you need to remember is that 0 factorial is a 1. That's important. So let's contrast this. This is a combination problem. This problem here is definitely a combination, not a permutation, because order didn't matter. But let's contrast that with this next problem where I say, how many ways can 2 students be chosen as president and vice president? Now the order matters. Whether A is president and B is vice president, or B is president and A is vice president, they're 2 different ways. So this is what we call a permutation. Order matters. So if I'm choosing 2 students, so in your calculator, 2 students from group 3, this is an n permutation R, and it doesn't have this same, that's a combination, that the parenthesis thing is for combination. But the formula for that is very similar. It's n factorial over n minus r factorial. And there's actually a simpler way to do this generally. So n is the size, this is how many are in the total group, and this is how many you leave out. N minus r is how many you leave out. So in the case of our 3 permute 2, what we get is 3 factorial over 3 minus 2 factorial, which is just 3 times 2 over 1, which is 6. So here we got, I never did actually finish this, 3 times 2 over 2 times 1 over 2 times 1. Here I got 3. There are 3 combinations, but there are 6 permutations because each pair has 2 ways they can be ordered, so the order is important. What you notice is the only thing missing from this. See that R? It's missing. So this part of the formula here is how many permutations. You need to divide by the fact that that combinations are counted multiple times depending on the size of the combination, but how many ways you can order them. So if you want to know how many ways can you order 3 things, it's 3 factorial. How many ways can you order 5 things? It's 5 factorial. The other way to think of this, and this is more commonly what students choose to do, is this. Let me get a better pen. The other way to think of this is I have 2 seats to fill, a president and a vice president. So I have 3 students, A, B, and C is my set. They're my 3 students. They have very boring names. So how many choices do I have before I've done anything? How many choices are there for the 3? Well, I can choose any one of these 3. Now, once I choose one, they are no longer available to be chosen for the next position. So let's say I chose A, there's only 2 left to choose from. No matter which one I cross off, there'll still be 2 left. So you just multiply those together. It's kind of like the sandwich problem. The sandwich problem was a combination because the items are all different. It's also kind of a permutation, but you couldn't put a meat in the position of the bread. So it's not quite the same. But this comes out anytime you just want to know how many ways can you choose with order mattering. It's just I can choose 3 here, and then I can choose 2 here. And that is how this formula works every time. Because let's say I was doing a 7, I had 7 in the group, and I was only choosing 2. The first position would be, I'd have 7 choices from my class. The second position, I'd have 6. So that formula would be 7 factorial over 2 factorial. Well, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 factorial. So you go down to the number that matches here and just write the rest. You cross out the 2 factorial, and you get 7 times 6 times 5 times 4 times 3. I guess that's filling, oh, wait a minute. I didn't do n minus r. Here's my mistake. I did r. I needed to do 7 minus 2 down here. So that's a 5 factorial. Forget I did that. Let me do it again in different colors. So I used the wrong number at the bottom. I didn't mean to confuse you by doing that. I'm trying to do this quickly. And maybe you can hear my phone's going off because I have to go to class. But if I have 7 factorial over, it should be how many there are divided by what you leave out. If you're only picking 2, you're leaving out 5. That's 7 times 6 times 5. And if I write 4, 3, 2, 1, that's just 5 factorial over 5 factorial. And there's my 7 times 6. So I didn't quite do that right there because I had the wrong number on the bottom. Those are the things you have to be careful of. All right, I will come back and finish numbers 3 and 4 in the next video. Thank you for joining me.